Imagine a quantum developer sitting down to test a new algorithm for optimizing logistics routing. They open the dashboard, paste their Qiskit circuit code into the collaborative editor, and specify parameters. Simulate with 1000 shots, then run on IBM's Manila hardware if the simulation metrics meet their threshold. The dashboard automatically formats the experiment, tags it with their username and a timestamp, and initiates the workflow. Within minutes, the developer sees an interactive infographic showing the simulation results, probability distributions, error rates, and quantum volume metrics rendered with clean animations and highlighted anomalies. The same interface displays the live status of the hardware run, including queue position and estimated completion time. Once finished, the full experiment record raw data, circuit diagrams, parameter settings, and hardware telemetry is stored in a versioned repository. Teammates can click replay to rerun the exact same configuration weeks later, even if the original hardware has been decommissioned or Qiskit Cirq libraries have updated. This reliability starts with Qiskit and Cirq handling the quantum workload orchestration. Qiskit compiles the developer's circuit into machine-specific instructions, while Cirq manages the pulse-level controls for fine-grained hardware interactions. Both frameworks feed metadata into Google Cloud's Node.js client, which structures the experiment artifacts into a cloud storage bucket. Infographic then transforms the numerical results into the visual narrative the developer sees, using its AI-friendly syntax to highlight trends a human might miss. Meanwhile, Checkmate monitors the entire pipeline, alerting if the cloud functions exceed latency thresholds, if the quantum hardware API returns errors, or if the dashboard's backend services start consuming excessive memory. Each component has a clear lane. Qiskit and Cirq are the quantum workhorses, Google Cloud handles persistence and scalability, Infographic turns data into insight, and Checkmate keeps the infrastructure honest. Together, they create a feedback loop where experiments aren't just run but institutionalized as reproducible knowledge. The developer never has to worry about environment setup or result integrity. The dashboard abstracts the plumbing, exposing only the dials and views needed to push the science forward. A quantum developer starts by designing a circuit using Qiskit, defining qubits, gates, and measurements in Python. They save this as a .qiskit file, which is essentially a JSON serialized representation of the circuit structure. This file gets uploaded to the dashboard via a REST API endpoint hosted on Google Cloud, specifically through the Google Cloud Node backend. The API contract here is a POST request to the experiment's API endpoint with the circuit data in the body and headers specifying the framework, Qiskit or Cirq, and simulation parameters like shots or backend type. Once received, Google Cloud Node validates the payload against a predefined schema, checks authentication tokens, and stores the raw circuit data in a Cloud Firestore database. This storage entity, called experiment, includes metadata like timestamps, user IDs, and status fields. The backend then publishes a circuit received event to a Cloud Pub subtopic, triggering the next stage. A worker service, also part of Google Cloud Node, subscribes to this topic. It pulls the experiment data from Firestore, checks if the circuit is from Qiskit or Cirq, and routes it to the appropriate simulator. For Qiskit circuits, it uses Qiskit's transpiler to optimize the circuit for the target backend, simulator, or real hardware, and executes it using Qiskit's Air simulator. Results are stored back in Firestore as a new simulation result entity linked to the original experiment. The backend then emits a results-ready event. Here's where Infographic comes in. A separate service consumes this event, queries Firestore for the result data, and uses Infographics API to generate a visualization. The API contract here is a POST to the Visualize API endpoint with the result data and a template ID, for example, quantum histogram or Bloom filter. Infographic renders the SVG output and stores it in Google Cloud Storage, returning a signed URL to the backend. Finally, Checkmate monitors the entire data flow. It tracks the latency of each API endpoint, like the experiment's API endpoint, the uptime of the Qiskit simulator containers, and the health of the Firestore database. If any component fails, say, the Qiskit worker crashes, Checkmate sends an alert to the dev team via Slack and logs the incident in its own database, creating a system alert event that's also stored in Firestore for traceability. This entire data flow ensures every step from circuit creation to visualization is logged, versioned, and queryable. A developer can later retrieve an experiment by ID, see the original circuit, simulation settings, results, and even the health metrics of the system when it ran, all through the dashboard's unified interface. Start by scaffolding the core quantum workflow. First, integrate Qiskit and Cirq side by side using a routing layer that detects circuit syntax and hardware targets. Build a unified circuit parser that normalizes both frameworks' outputs into a common intermediate representation. This lets users write code in their preferred framework, but share experiments seamlessly. Use Qiskit's transpiler for optimization and Cirq's native pulse controls where needed. For local development, containerize the quantum runtimes. Create a Docker Compose setup that spins up separate services for Qiskit's Air simulator, Cirq's Google Cloud integration, and a mock hardware emulator. Use env files to toggle between real quantum backends and simulators. Set up a Python task runner that parallelizes circuit execution across available backends. Testing pyramid. Start with unit tests for individual circuit components, using PyTest fixtures that mock quantum hardware responses. Then layer in integration tests that verify full experiment pipelines, circuit creation, simulation, result storage. Use temporary databases during CI to ensure reproducibility. For end-to-end tests, implement circuit diffing that compares expected and actual results within statistical tolerance thresholds. Background jobs handle long-running simulations and result rendering. Use a task queue like Celery with Read as broker. When a user submits an experiment, the system creates a task that 1. Executes the circuit on chosen backend, 2. Stores raw results in MongoDB via Google Cloud Node, 3. Generates visualizations using infographics API, 4. Updates the experiment history. Implement retree logic with exponential backoff for transient hardware errors. Production deployment uses Kubernetes clusters with node affinity for GPU-enabled machines running quantum simulators. Deploy Qiskit and Cirq as sidecar containers that share circuit definitions via shared volumes. Use Checkmate for monitoring both application health and quantum hardware metrics. Track circuit success rates, qubit calibration status, and backend queue depths. Configure alerts for when hardware availability drops below 90% or simulation times exceed expected baselines. For the dashboard, build a GraphQL API that surfaces experiment metadata, raw results, and visualization assets. Use infographics Node.js bindings to dynamically generate circuit diagrams and statistical summaries. Cache frequent queries with Redis. Implement authentication using Google Cloud IAM, mapping users to their experiment history. Version control follows GitOps principles. Each experiment commit triggers a pipeline that builds Docker images, runs tests, deploys to staging, and on approval, pushes to production. Use Checkmate's API to track deployment health and roll back if quantum hardware metrics degrade post-deployment. Store all experiment artifacts in versioned S3 buckets with lifecycle policies for cost management. This architecture ensures reproducibility by treating circuits, parameters, and environments as immutable artifacts. Every experiment run gets a unique hash combining code, data, and backend version. Background workers automatically garbage collect unused artifacts after 30 days unless pinned by users. To tie everything together into a cohesive quantum experiment dashboard, start by setting up Qiskit and Cirq as your quantum development backends. Install Qiskit via pip with pip install Qiskit to handle circuit creation and IBM hardware integration, ensuring you have Python 3.6+ and optional Rust compiler for source builds. For Cirq, run pip install Cirq to enable Qiskit noise modeling and Google Quantum AI compatibility, leveraging its parameterized circuits and simulators. Both frameworks allow exporting experiments as standardized JSON or OpenQSM for reproducibility. For data orchestration, integrate Google Cloud Node by initializing a Node.js project with npm init and installing specific service clients like npm install at Google Cloud Storage if your dashboard requires cloud storage for experiment history. Use environment variables like Google application credentials to authenticate with Google Cloud Services. Visualize experiment results using infographic by defining a declarative configuration file. For example, create a report YAML with template selections and data bindings, then generate visuals via npx infographic render, config report YAML. Infographics 200 plus templates simplify turning simulation metrics into shareable insights, though complex custom designs may require direct SVG editing. Monitor dashboard uptime and hardware metrics with Checkmate. Deploy via Docker Compose using the provided Docker Compose DOML, which spins up Checkmate and MongoDB. Access the UI at and configure monitors for API endpoints or quantum hardware health checks. Note that Checkmate's agent capture must be separately installed on servers for detailed resource tracking. All components are open source under permissive licenses. Apache 2.0 for Qiskit Cirq and Google Cloud Node, MIT for Infographic and Checkmate, with no mandatory costs. Self-hosting requires managing dependencies like Rust for Qiskit builds or MongoDB for Checkmate. Today, a developer could run Docker Compose up to launch Checkmate's monitoring, then install Qiskit and Cirq in a Python environment to start building reproducible quantum workflows. What's your experience been like with quantum frameworks? Do you prioritize hardware integration, simulation flexibility, or collaborative tooling?